do so. That's fine. So I'm going to record. Shema, if you can't hear me, let me know, but I think you can hear me. So yeah. There we go. So let's have a look at our slides. Right. Make that a bit bigger. So today's lesson is just on this topic of selection. Selection being a choice between alternatives. So the alternatives that we have in computing, sometimes we refer to this as branching. That means that a computer program can branch to different directions. So different parts of the program could be processed depending on a choice at a branch, which we refer to as selection. So as it says here, we've learned in our earlier lessons about CPUs, the fetch and decode and execute cycle. You might remember that. But how that works is that one command at a time. And so the order which the commands are given in the program, that's the order that they're executed in, except that we have this situation here. Now, it actually refers to two different situations, two different main possibilities, but they both have something in common, which they have a condition, which if the condition is true, then the program proceeds in one direction. And if the condition is false, then the program proceeds in a different direction. And there's all kinds of sort of combinations of conditions and branches that you can have so that you can make a computer program quite complicated there. So we have this issue of a loop. It refers to a loop, which is what's going to happen there is the branching will take you back to a previous statement. And so every time you get to the condition, you'll just go back to a previous statement until the condition becomes false, and then you continue on. And so that's a loop where you're repeating a block of instructions. And I think I've shown you that already in class a couple of times with Python, where we had the birthday, how old are you? And then we said, happy birthday, how many times? That was a loop. The other one that we did was, we had another loop, which just, what was it? What was the first loop that we had? I can't remember. I just remember the happy birthday one. Yeah, the numbers of, what was it? Yeah, from 1 to 90, and we just said hello or something. Yeah, that's why it was hard to remember. Right, so there's this fellow here. His name is George Boole. So he's a mathematician. So this idea of we actually have this idea which we call Boolean algebra. There is a video which I put a link to in today's news. So it's only 4 minutes long. I'm not going out and finding 50-minute videos for you to watch. All right, so don't worry about that. It's a 4-minute video. I do highly recommend it to you. It will show you some symbols that you may come across when we talk about this idea of Boolean. Now, I haven't seen it as being part of our lecture notes, but it is in the textbook. So, well, we have a textbook reference book, uses the symbols that are in that video. I'm not going to go through them though, because I've got this lecture for you, but I do recommend it. It's a 4-minute video. The link is there. But that video is about Boolean logic. Boolean logic. You might guess, if we're talking about a British mathematician by the name of George Boole, that maybe Boolean and George Boole had something together. Yes. So his name was given to this form of logic. The idea being that something is either true or it's false, right? You can't be both true and false. You're either true or you're false. And so you can also introduce the idea of negation, where you can have a whole set of things that could be true, and if we put a not in front of it, then everything is reversed or inverted. Now, not all statements are Boolean. These are some statements that could be Boolean. When we say they're a Boolean type statement, we can apply Boolean logic to them. That means that they are either true or false. They are a condition which is either true or false. You're either hungry or you're not hungry. There's a city is either the capital or it's not. A person is either over age 18 or they're not. And a name can has either less than 2 characters or it doesn't. I mean, that's Boolean. Now, there are other conditions or statements that we could make that are not Boolean. How old are you is not a Boolean statement. It's not true or false. You know, it's an age, it's a number, right? So that's not a Boolean type statement. The result of adding 2 numbers together, that is not Boolean. All right, so I hope that makes sense to you. When we do Boolean, what we're looking at is we're looking at a condition which is either true or false. And so we use this term decision, and you've seen in your flow charts a decision symbol, which was the diamond symbol, which every time we had a diamond symbol, we would have usually 2 possible outcomes from it, depending on whether the condition in the diamond was true or false. And yeah, let's see. So the decision is going to represent a point in the program where you're going to have that branch, where the program is either going to proceed down one way or proceed down another way, depending on whether that condition is true or false. We've got an example of a program here is, well, when I say a program, it's an algorithm at this point. Sorry, I was trying to, what else should do is this. Now I am leaving you with the notes down the bottom, just so that you can sort of get an idea on what's happening. I'll make this a bit smaller so we can see it completely. Hopefully you're familiar now with all of these symbol shapes and things like that. So you've got those very, very significantly rounded edges, or that's going to be our start and stops, start and end, or I called them connectors before. I hope you recognize the inputs and outputs, which are these, they're parallelograms, but they don't have 90-degree angles. A process is going to have 90-degree angles, so it's going to be a rectangle. Now, what we've got here is we've got a decision. And so what's happening is there's an input into a variable called amount, and then we test that variable and see if the value is bigger than 1,000. If it is bigger than 1,000, then we would follow the arrow coming out saying yes. We could have said true there, right? So if it's true, we go that way. If it's false, we go the other way. And what will happen is there's a branch in the program that if it's false, we're going to skip this process here. Now the colors don't mean anything, but I hope that you can see there that the program will process differently depending on whether that condition is true. If it's false, we don't do this process here. And so what this means in case of this is if you don't have an amount more than $1,000 or 1,000 whatever, you don't get a discount. If you do have an amount of over 1,000, then you do get a discount. And so your process is going to be different. Your amount is going to be calculated differently. Then we continue on through the other things there. So that's an example of branching. Now this could be put into a computer program with a simple if statement. The if statement would say, if amount is bigger than 1,000, then do this. And then it wouldn't have to have an else, because what happens if you have an if statement without an else is when you finish the thing, you've chosen either true or false, right? If it's false, we just go to the next line of code. And so that's what we see happening here. If it's false, we just go to the next line of code. Whereas if it was true, we're going to do this thing. So that would be an if statement without an else. We don't need an else because we just go to the next line of code. So that's one way of doing it. You'll see that we're going to have in a minute something that's going to be a little bit more complicated. And now I've got some chat statements. What's happening here? Yes, I can. Punishment flowchart. Okay. Yeah, that's right. The punishment. Thank you for the reminder. I will not copy, I think it was, 1,000 times. So the word we're using here that we haven't used before is a consequence. If something is true, the consequence of the condition. So if it's true, there's this consequence. If it's false, we have a different consequence. So two different consequences coming out of a statement. Now, in the previous one that we looked at, all we did is skip to the next line of code, which would be performed anyway. But let's have a look at, that's just the same as what we talked about, right? Waiter asks for the person's age. If the person is over 18, then they get this menu. But if they're not, we skip to the next line. So this again would be one of those statements which would just say, if age bigger than 18, do this. We wouldn't even need an else, because what we'd do if they were not is we just skip to the next line of code, which would be outside of the if statement. One a little bit more complicated. Now we're getting into the territory where we would have a if, then do this, else do that. So we're going to do different things depending on the truth of this statement. If a person, if the age, so that, again, we're at the restaurant and we have a kid menu, right? And so if the person is bigger than 10, we show them the regular menu. But sorry, bigger than 12. We show them the regular menu. But if they're not bigger than 12, they get to see a kids menu. Now, the important thing here is the person who's not bigger than 12 doesn't get to see the normal menu. They get to see a kid menu, but they don't get to see the normal menu. Again, the person who is bigger than 12, they get to see the regular menu and they don't get to see the kid menu. Does that make sense? So you got one or the other. This is going to be implemented in Python program. You would implement this with that. If age bigger than 12, show menu, else show kids menu. And then we go on to the next bits of code. And you can see that they are mutually exclusive. So what I mean by that is that you don't get to have both, right? You're either this one or you're that one, right? And that's how we implement an if then else in a computer program. So if one statement is executed will be true, then it can't be true and false at the same time. I guess that's all we need to say about that. So that's very neat, the way that works in Boolean logic. Let's have a look at the next one. Now, the idea of a nested selection is that depending on one condition being true, you may be asked another condition. And so let's see how this one works, right? So we're going to, all right. So I have to say, I find this one a little bit strange because I don't actually think that 55 is too old to go on a ride. I don't know. Yeah, I don't actually think the 55 is very old, but there you go. That must be because I'm kind of old. All right, so according to this place, right, if you're more than 55 or you're under 16, you can't go on this ride. So the question, so how this is going to work is a person could be asked the question, are you bigger than 16? If they're not, then they can't go on the ride. But if they are bigger than 16, maybe they can go on the ride, but maybe not, right? If you're over 16, then you're going to be asked the question. Now, you only be asked this question if you're already over 16, right? If you're not over 16, you don't even get asked this question. If you're not over 16, you just get asked, are you over 16? You're not, so you can't go on a ride. If you are over 16, then we got to check another thing, right? Are you less than 55? And if you're less than 55, okay, you can ride. But if you're more than 55, they're not going to let you ride. All right, so we do something like this. For a good one for this would be if we wanted to write a program to take somebody's score and turn it into a grade. That would be a good example of this. So if we're going to, and I'm going to write this on the board, so I don't know if the people, I think they can see me, but let's say we're going to get their grade. If the grade is bigger than 90, then what we would do is we'll say that if the mark is bigger than 90, then the grade will take the value of A, right? Else. So now we're getting to this if then else thing, right? So this would be the no. If the grade, else if grade is, sorry, not grade, if mark is bigger than, what's the next thing after that, 75 or something like that? Bigger than 75, I think, right, for a B? Or is it 70? Let's say 75. Then grade is a B. Else, if mark is bigger than 60, then grade takes a value of a C. Else, grade takes the value of an L. It's something like that. Okay, I think you've seen something like that. And I don't know, I might not be exactly right with the numbers here, but the idea is that this is nested. This is nested ifs, this is nested selections. If the grade is bigger than 90, we stop here. This is true. So we've finished, right? We're out of the loop. We don't even look at all these others, because if you're bigger than 90, we don't care, right? But if you're not bigger than 90, then when I say we don't care, we just give you an A and then we stop. But if you're not bigger than 90, then we're going to say, well, are you bigger than 75? Well, if that's true, then we do this. But if it's not true, then we go to the other one. So we got this one here is doing the nested if with the trues. We could have, I've shown it on the board here, doing it with the falses. But that's an idea of a nested selection or a nested if. And the one that was in your notes had two selections, and the one that I just put on the board had 3 or 4, right? So you can do this many, many times. But the thing is about the logic of it. I hope you can see the logic here, right? It's say somebody had a score of 50. Is that bigger than 90? No. So we have to go to the else. The else means no, means false. Is 50 bigger than 75? False. So we have to go to the else again. Is 50 bigger than 60? No, false. So we go here. And that's where we stop. Does that make sense? Nested if, nested selection. Could have 2 conditions, could have 3 conditions, could have 4 conditions, whatever. Now we're going to, and for this stuff here, especially if you find this even a little bit hard, which I hope you don't, but it's possible that you might. I do recommend that 4-minute video that I've given you, right? Please do have a look at that. It's only 4 minutes. It's not 40 minutes. And he uses the symbols there, but he does talk about these things, the and, the or, and the not. Actually, he starts off talking about the not. All right, so we have these special terms. No doubt these will show up. Now, somebody's going to ask me, is this going to be in the test? I don't believe this is in the test. All right, it'll be in the next test. But it won't be in the test that you're going to have in the next lesson that we have that test of it. Well, let's look. So and is used as a logical operator. We can put 2 different conditions together and join them with an and. And what that means is both conditions must be true for that conjunction to be true. And so let's see what I mean. We put 2 conditions together, condition 1 and condition 2. If we put the and between them, the whole thing together will only be true if both condition 1 and condition 2 are true. So if condition 1 and condition 2 are both true, then this would be true. I don't know, maybe we need an example. Oh, we do have some examples that are coming in. We'll talk about those. Or is a disjunction. And what that is if you put 2 conditions together joined by an or, only one of them has to be true for the whole thing to be evaluated as true. And so that's how, let's look at examples. I hope this will work. All right, so this is falsifying them. If you're falsifying an and, the reverse is, it talks about them being inverted. So if you have two conditions that are put together with an and then you reverse that by saying not, then if either of them is false, or so we can, the reverse will be an or. The reverse of an and is an or. The reverse of an or is an and. I think I need to show an example on this to get you the idea. So let's see. Here's an example. So we got two conditions, clean and new, and they are joined together with an and. For this statement to be true, two things have to be true because they're joined together with an and. The car must be clean and it must be new. If either of those is not true, then the full statement is not true. So if the car is dirty and new, then this statement's not true. If the car is clean but old, then this statement's not true. The statement is also not true if the car is dirty and old. So the only time, so this is a very limited, the conjunction, very limited. It can only be true if both of these things are true. And hopefully that makes sense. If the car is clean but old, it's false. If the car is dirty and new, it's false. If the car is dirty and old, then it's false. So now the negation, or the opposite of this, if you said, your car is not clean and new. Your car is not clean and new. That could be true if it was either not clean or it was not new. If we said it's not clean and new. Your car is dirty or old. Either one of those would be true if that thing was false. Let's look at it with the disjunction. We put the two conditions together now with an or. Your car is clean or new. If either of these things is true, then the statement is true. If the car is clean but it's old, then the statement is true. If the car is new but it's dirty, then the statement is true. If the car is clean and the car is new, then the statement is true. The only time it's not true is if the car was both dirty and old, then this would not be true. And so notice that the negative of this is going to be and. The car, if we say not, car is new, clean or new, then what we're, another way of saying that is your car is dirty and old, because the opposite of clean or new is dirty and old, right? It would have to be both of those things because the or allows either of these things to be true, the whole thing's true. So for the opposite, both of them would have to be false. Both of them would have to be false. So that's what that means there. And so I don't think that I'm supposed to show you that answer like that. What I think I'm supposed to do is make this like this. Yeah, all right. So yeah, we got that. We just finished that. Right, let's negate these. What's the opposite of the car is beautiful? The car is not beautiful, or the car is ugly, or something like that, right? What's the opposite of next weekend I will go to the beach or the desert? The opposite. Good. I will not go to I won't go to the beach, and I will not go to the desert. All right. It's kind of weird with the English there, right? I like burgers and pizzas. The opposite. I don't like burgers or pizzas. Yeah. I mean, the English is kind of get around it. And so the English is a bit weird here too, because I think when you look at the but here, you're going to have to look at that as if it was an and as well, because that's joining them. This course is interesting and this course is difficult, I think is how you should read that. So what would be the opposite of that? The opposite of this course is interesting and this course is difficult. Yeah, of course, it's not interesting or difficult. Very good. He's between 18 and 35 years old. There's an and in there. So you could say the opposite would be he is not between, that's just dumb. He could be less than 18 or he could be more than 35. But you could just say he's, yeah, anyways, he could be less than 18 or he could be more than 35. I got an A in the midterm or I dropped the course. The opposite of that would be and I didn't drop the course. You'd have to put an and in it because it'd be the opposite. I did not get an A and I did not drop the course. Sorry, the English in there was kind of weird. And or and. Yeah, all right, fine. Okay, so do you remember we did this in the last one, right? But we've got to do something a little bit more to it. Draw a flowchart for the program called Fahrenheit to Celsius that asks the user for a temperature in Fahrenheit and displays, okay. If the temperature is below 0 degrees, display the message it's freezing. If the temperature is above 100 degrees, display the message it's boiling. And then we're going to test it with some temperature. So what I'm going to do is I'm going to quit the lecture now, and we'll do this on the board together, I guess, right? Because no point recording this because we're going to be playing on the board. All right, so I'm going to stop the share. Thanks. I think that's Shema. See you later. Shema and Frank. All right, see you.